All right. Hey, everybody. I just had to make this video real quick because a thought popped in my head, and it is about gravity, Newtonian physics, the rate of free fall, and the size of the Earth. Okay. If, in fact, gravity is not what we've been told it is, because it is a theory, okay? It's a theory. But it is that. But if it is, uh, the reason why it's a theory, it's a theory, is because it cannot be replicated in a controlled environment. Okay, science is something that you can replicate, duplicate, and you will get the same results. Okay, so if there's any science that you've been told is science, okay, but you cannot test it, then it's not science. All right, some of us in certain circles know this. All right, so when you have someone who is a theoretical physicist, he is not offering you science. He is offering you exactly what I offer in my comic books. He's offering stories that make sense within his own creation of within his own creation of physics. Okay. Just like I can say kryptonite affects Superman because the radiation that leaks from kryptonite has a negative effect on the cellular structure of Kryptonians, which Superman happens to be a part of that race. All right, so my physics work out, the math works out because I have created a completely false paradigm. All right, that's not science. Science is something that you can replicate, that you can test. All right, so the fact that an object, because of its size, will pull another object to it is not testable. It doesn't happen in reality. Okay? Now, well, not to the extent that they're saying. All right. Uh, the only thing that I can think that comes close to that is surface tension. But if I were to put two giant balls of paper beside one another, they're not going to pull themselves towards each other. I don't care if the ball of paper, if one ball is 1,000 times larger than the other, it's not going to pull even a cotton ball towards it. It's just not going to happen. Okay. But there is another phenomenon that does explain this, and that is electrostatic charge. We do know that electrostatic charges will pull objects towards it, regardless of that object's makeup. So it's not necessarily magnetics. The object does not have to be a metal object for an electrostatic charge to pull an object towards it. Okay? If an object is electrostatically charged, it has a certain pull on the electromagnetic fields around it. Okay? And it will pull objects into it. If you're trying to understand what I'm saying, it's just like if you rub a balloon in, on your pant leg and then you put it towards your hair. It won't work on my hair. Oh, actually, it will. It will. It's just not as noticeable. But if you have a longer, thinner type of hair, your hair will stand out. I can do it on my hair on my arms, and it'll stand up there. Okay. On the old television screens, the old tube televisions, they would be electrostatically charged. You would watch as you turn them on. You could actually see the dust in the air get pulled towards the screen. Okay. The screen doesn't suddenly have gravity. What it has is it's electrostatically charged. All right. So you can prove this. You can prove it. You can test electrostatically charged items, and you can realize that they have a pull. So the electrostatically charged Earth is more scientifically sound, based in the parameters of science and Newtonian physics, than what they say gravity is. Because in order for gravity to work in the way that they describe it, they have to construct a new fictional creation called dark matter. All right, this is just like me saying kryptonite. All right, we don't know what dark matter is. We've never seen it. No one has ever tested it. It's a completely made up concept to explain another completely made up concept, which is gravity. Okay, but in the world of science, there is a testable and demonstrative element called or event phenomenon called electrostatic charge. All right. Now, here's the big reveal. Okay, there's something called a rate of free fall in Newtonian physics. There's something called a rate of free fall, where the only elements acting upon the object is quote unquote gravity. But what I'm going to say is where the only elements affecting upon a product or upon an object is electrostatic charge. Okay, that means even if you were to take an object outside the air and the atmosphere, okay, and you were to put it in a vacuum, whatever rate that it is falling towards the floor, which is the electrostatically charged object, is the rate of free fall. Now, what I'm about to drop is some deep stuff. Okay? What I'm about to drop is some deep stuff. The rate of free fall in an electrostatically charged model is directly comparative to the amount of electrostatic charge that object is emitting. So what am I saying? If you turn the TV on and it pulls the dust particles towards the TV screen at very slow, that means that the TV only has a certain amount of charge. It's charged at a lower rate. If you turn it on and it pulls the dust particles this much faster, right, then it has more of a charge. Okay? Well, two possibilities. The TV has either more of a charge or it has a larger surface area, creating a larger, stronger, electrostatically charged field. That's what I'm thinking. I don't know if that's right or not. But it's what popped in my head, so I had to get this out. So, the idea that I'm thinking is this. Is if you can figure out the rate of free fall, which you know the rate of what the rate of free fall is, how much of an electrostatic charge that takes to create that type of speed on an object, then you will know the electrostatic charge of the Earth, and or you will also know its size to generate that amount of an electrostatic charge. The true size and nature, or at least the electrostatic charge capacity of the Earth we live on. Now, how's that? How are you going to do that? I don't know, but I would start by I don't know. And now that I think about it, I see some holes in it, but the just the holes in whether or not it will reveal size. But I think you can definitely find the charge. You can find the level of charge just by the rate of fall. You can definitely do that. So anyway, just thought I'd put that out there. See what do you guys think? Peace.